Welcome back. We're going to talk about circles this time. And of course, equations having to do with circles, and a small application at the end. Okay, what's a circle? First of all, if you're talking about a circle, you don't do anything until you have the center. That's the beginning. The second part is, how far away are those points going to be from the center? The radius. Here's the center, here's the radius. All these points that are the same distance away make up the circle. I know that doesn't look like a circle, but use your imagination. Here's an equation. This equation has a lot of information in it. The nice thing is that the numbers right here, h and k, tell you where the center is. And r squared is the radius squared. So if you have just a regular number here, take the square root, and that's going to be the radius. So the easiest one is if you're at the origin. If you're at the origin, then h and k are both 0. So what you have is a circle with a center at 0, 0 has this equation. Nice and simple. They're not all quite that simple though, but that's a good starting point. So let's find the center radius form of the equation of each circle is described. So let's take this one. So we've got the center there. Let's start with the basic equation and start filling things in. Okay, what's h? H is -3. K is a 4. R is 6. So we'll put the numbers in. So we've got x minus a -3 is +3 squared plus y minus 4 squared equals 6 squared. We want the center radius form, so x plus 3 squared plus y minus 4 squared equals 36. Okay, that's it. And we wanted the center radius form. That's why we end up with this. If we want it in standard form, then we'd expand those two binomials and take the numbers on the other side, or bring this number on the other side. And there we go. How about this one? We want the center radius form, which is good. Now, x minus what? H is 0, so h minus 0 squared plus y minus 0 squared equals 3 squared. Of course, this is just x squared plus y squared equals 9. And of course, you could have jumped right there because you already know that if the center is a 0, 0, it won't have an h and a k that's visible. And there you go. Now, how do you graph it? Okay, fortunately, it's in center radius form, so right away you know that the center is at -3, 4, and the radius is 6, alias the square root of 36. How do you graph it? Okay, this is not the best, but so negative 3, 4. Let's put some hash marks on here. Maybe I need some graph paper to throw in these. I'll have to see about that. Okay, negative 3, 4 is the center. So negative 3, 1, 2, 3, 4, 1, 2, 3, 4. There is the center. Now we have the radius of 6. So what we can do to make it easier on ourselves is we're at negative 3 right here. What I'm going to do is 6 is in every single direction. Well, you can't go to all those places. What I'll do though is, starting from the center, I'll go 6 to the right. It'll be one of those points. So 1, 2, 3, 4, 5, 6. And there's one point on the circle. Then this is at 4, so I'll go up to 10. Let's say it's up there. Then I'll go from here over in this direction 6, and I'll go from here down 6. I've got 4 points on the circle, and all I need to do then is just carefully draw what looks like a circle, a nice curve. Not the greatest, but I think you get the idea. That's how you do it. Start with the center, go 6 and to the right, left, up and down, and then smoothen the curve. And let's see how they do it. Okay, first thing, well, we already knew this part, so we didn't have to do that. But if not, remember this right here is K. But to get H here, you need it in the form X minus. And plus 3, if you have a minus here, you'd have to be a minus 3, like that. Plus 3, so it'll be the opposite. And that gives you the center, and 6 is the radius. And that's a much better look at it, but I think you've still got the idea. So graph this circle, okay? Okay, we're ready to roll here. Now, x squared plus y squared equals 9. Right away I know the center is at the origin. So here's my center. And if you follow what I did previously, remember this 9 is 3 squared, so the radius is 3. So I'm going to start here at the center. There's 1.3 units to the right. Another 0.3 units up, 3 units back, 3 units down, and then, as well as I can, create a circle that goes through those 4 points. And there you go. Not too bad considering it was longhand. Now that was the center radius form. This is the general form. Notice one special thing. Zeros on one side, everything else is on the left. And you can have a graph that's a circle or a point or is non-existent altogether, which sounds sort of strange, but keep that in mind. 3 possibilities. So here's something that looks like a normal circle. Now this is off the record, and your circle could be just a point, only one point to it, or it doesn't exist at all. So here are some things you can use to determine. So here's C. If C is greater than 0, like the ones we've been working with already, then R is going to be some positive number. We're in good shape. The point is, to find out what R is, we're going to have to take the square root of that, so it has to be positive. So there's the radius. And it's going to be a circle that looks like a circle. The second one, so this is the one you are familiar with. The second one is a little strange. It says if C is 0, that means this number out here is 0. What's that mean? It means the radius is 0, so when you start with the center, you're going out 0, which means you aren't going out at all. When you go to the right, you go 0 units, you're still there. When you go up, you're going 0 units, you're still there. No matter what you do, you're still there because the radius is 0. So it's just a single point. If that number on this side is 0. So I hope you got that. And third, if that number on the right with point radius format, if this number is negative here, remember you're going to take, to get the radius, you're going to take the square root of C. Well, if this is negative in here, for example, square root of negative 4, there is no square root of negative 4 that's non-negative. That's why the circle would be non-existent. The graph would be non-existent on our typical rectangular coordinate system or Cartesian coordinate system. You might want to keep these in mind. You're probably going to forget about these three as soon as you get to the end of this video. So take a note of that and what they represent. This means that we'll have a radius. This means that as a radius is 0, which means there are no points outside that circle center. And this means you don't have any circle at all, not even a point circle. Now we get to something a little bit more interesting. Notice up here it says, by completing the square. You've probably run into this before, and you probably have forgotten it. So how do I complete the square? Well, first of all, notice the x terms are next to each other, the y terms are next to each other, and there's maybe a constant out here. The first thing we're going to do is separate these, and we're going to leave a blank with the x's because we're going to be completing the square. Plus y plus squared plus 10y, leave a blank again. And what we want is get rid of that 18. So this would be a negative 18 over here. Now what we want to do is complete the square because we want it to look like this. Okay, so what do? Well, write these instructions down because they're important. In the meantime, I'm going to change the pen color temporarily. I'm going to use blue. So, what do I put in here and here so that they become nice squares like this? Here's what you do. Take this number right here, the one in front of the x, the coefficient of x. So I'm going to go up here. -6 is the coefficient of x. I'm going to do two things to it. First of all, I'm going to divide it by 2. Writing as a fraction is a big help. That's first. Second, I'm going to square that. So what do I have? This is -3 squared, or a 9. Now what am I going to do with that 9? Well, that's going to complete this square. And what I'm going to have down here, I'm not going to draw it in right now, I'll have x minus 3 quantity squared. It should look a little bit familiar. Now I need to do the same thing with the y's. Again, what's the coefficient of y? The coefficient of y is 10. Do two things. Divide it by 2, square the answer. So that's 25. So over here, to complete this square, I'll add 25. That's the 10 divided by 2 and squared. That goes in here. Now notice what I've done. I've added 9 to the left-hand side, and I've added 25 to the left-hand side. All told, I've added 34 to the left-hand side. What's wrong with that? Well, it's not equal anymore. To balance it out, I have to take that 34 that I added over here and add it to the other side as well. Now it's balanced again. Now we can write that equals. Now we're ready to keep going. I'm going to go back to the red again to be somewhat consistent. Okay, so what we need to do now is we've completed the square. We need to factor it because what we wanted is for it to look like this. Now, one easy way of figuring out what this is, you could just say that's the square root of this and then use this sign, or you can just say, okay, what's half of the -6? It's a -3. And then expand this binomial, and that's exactly what you should get right above that. Plus. Now notice you got a y here, you got a 5 here, and if there's a plus there, this will be a plus. We have factored the completed square. Now, what do we have here? 34 minus 18. What do we get? 16. Well, that sounds really good to me because that's 4 squared. So I've got x minus 3 squared plus y plus 5 squared equals 4 squared. So the radius is 4. Now what's the center? Remember, the center is the point HK. And if we think of h or x minus h here, the center has an x coordinate of 3. Now this one doesn't have a minus, so we have to think of it as y minus a -5. So we can look at this one and say that's the y coordinate. So this will be a -5. It will always be the opposite of whatever this number is right here. So that's the center. And the radius is, of course, the 4. square root of 16 or 4. There you go. That's finding the center and radius by completing the square. Get plenty of practice on this. You're going to have to do this 5, 10 times until you get it down. You've got all the pieces, you just have to put them together to complete the square. Okay. And if you follow these slides that I put in Blackboard, you can follow it yourself. And also maybe take a second look at this video and follow it there too, after you've looked at the PowerPoint all by itself. So there we have it. Circle with center at 3, -5 with a radius of 4. How about this one? This is good practice, but also we've got a little wrinkle that we didn't have before. In the previous one, you had, let's see, I'll sneak up here. In the previous one, you had x squared and y squared. Point is, it was 1x squared and 1y squared, which made the factoring much easier. We have 2x squared and 2y squared. So to get these, to make it easier to work with, we're going to divide everything by a 2. So dividing the first one by 2, you get x squared. Divide the second one by 2, you get y squared, minus, make sure you keep dividing by 2, minus 3x plus 5y equals, don't forget the guy over here, 1/2. Divide everything by 2. That gets you your x squared and your y squared that you need. Now, hello? We're going to complete the square.
I'm having trouble with the connection. Please try again later.
My phone just interrupted. That's never happened before. Okay, let's get back here. So we're ready to complete the square. Now you might want to go back and watch the last one all over again. We're going to do the same steps, but some of the steps are going to look, well, the results are going to look a little bit strange or tricky because we'll be working with fractions a little bit more. So here we go. First of all, I'm going to put these in a different order. I'm going to put the x's together and the y's together. So x squared minus 3x, put that together. And then over here I'll have y squared plus 5y. Notice I've left blanks there. And on this other side, it's still 1/2. That's good. Now I'm ready to complete the square. And I'm going to switch back to blue. There we go. So what goes in here and what goes in here? Well, in the last one, I took the coefficient of x and the coefficient of y and found out what goes in these two spots. So over here, I'll take the -3. What did I do? Two things. Divide that by 2 and then square it. What do I get? Well, it'll be -3 squared over 2 squared. It'll be 9/4. Remember, take this, divide it by 2, and then square your answer. That gives you the 9/4. Over here, what do we get? Well, we'll take that 5, divide it by 2, square the answer. What do I have? What I'll have is 25/4. Now remember the deal the last time? If I add things on the left side and don't add them on the right, I don't have equals anymore. That would be a catastrophe. So I'll have to add 9/4, and temporarily I'm going to make this 2 1/4, and the 25/4 will be 6 1/4. And let's see, what do I have here? Well, fortunately, I've got 1/2. The 2 and the 6, that gives me 8. I've got a half plus 1/4 plus 1/4, that's 1. I'm in good shape. It looked as though it was going to be pretty nasty, but it's pretty good. Now, I need to factor both of these because I've just completed the square. That means I can write it as a square. And that's equal to 9, and I know I'm going to want to write that as 3 squared. Now, what do I have? I've got an x here and a y here. Because there's a minus there, there's a minus here. Because there's a plus here, there's a plus there. Now, what are those two numbers? What was 9/4 before it was squared? All we have to do is take the square root of the top, square root of the bottom. It's x minus 3/2. Over here, 25/4, take the square root of both, y plus 5/2. Now we're in business. We want the center of the radius. It's almost right in front of us. The center, where is it? Well, the center is a 3/2 for the x. And remember, it's going to be the opposite of this 5/2 because I need y minus a negative 5/2. And there's my center. And the radius is 3. And there you go. That's as difficult as you're going to have. If you can do that, you can do any of the other ones. It looks familiar, right? And there it is with the minuses and with the squared radius on the right. And there's our answer. Next, is it a point or is it non-existent? What does that mean? What it means is we need to look at this number right here. So there's our equation. We bring the 33 to the opposite side. Notice we've got a negative 33. This is going to represent r squared, remember? This could be a problem. It might not be. Let's see. So I'll take this 10, take half of it, square it. Half of it is 5, square it's 25. So I'm going to put the 25 here. On the other one, I'll take half of negative 4, that's negative 2, square it, 4. So I'm going to add 29 to both sides, like that. Notice this and this, excuse me, means we're adding 29 to the left side in a crafty way, let's say. And there's the 29 added to the right side. The square is completed. So there we've got it. This in center radius format. something should look bad to you. If I'm squaring two numbers, each one of those can't be negative. This is not negative, that's not negative. When I add them together, I can't get a negative answer. What's that mean? There are no ordered pairs, and the circle is non-existent, has no points. Remember, if we'd ended up with 0 here, it would be a point circle. Anything positive, and we've got a normal circle, let's say. Okay, we're going to wrap this up a bit with talking about an earthquake. Now it says, suppose receiving stations A, B, and C are located on the coordinate plane. So, first thing you might want to do is find out what these look like. So I'm going to rough this in. 1, 4 might be something like this. -3, -1, something like that. And 5, 2, something like this. Where is the epicenter? In other words, these are the same distance oops. Nope. Let me back up. So you've got, see, A is here, B is here, C is here. And the distances from the epicenter, wherever that thing is, somewhere in here, oops, to the first one, to A, let's say it's here, just for fun. This is 2 units. To B is 5 units, and to C is 4 units. So graph the 3 circles. When you graph those 3 circles, you'll take A, for example, and it's got a radius of 2. It's 2 miles or 2 units from the center. So you draw a circle with a radius of 2. Then you go over here to B. B is 5 away. So you make a circle of radius 5. Then you go over to C. It's 4 units away. Not exactly like that, but that's the basic idea. Now, once you graphed it, now you really need graph paper for this. You should notice that the epicenter is about at 1, 2. Now, of course, with this picture, I'm not going to get even close. But when you do it on decent graph paper, those circles should all hit 1, 2, at 1, 2. And you can check that algebraically. Take the point 1, 2, and put it into all 3 circles. Circle A, let's put it this way. Circle A, circle B, circle C's equations. See if it works in all 3. If so, then that is the epicenter. That's what the picture should look like. Notice the all cross right here. That's where all 3 cross. Now 2 cross here, but that doesn't count. 2 cross here doesn't count. This is the one that really counts. And you check the coordinates for this, which are about 1, 2. Check it in each of those equations. Here's for equation A. Check 1, 2 in here. Make sure that works. That works. Does it work for B? Check that point. 1, 2. You might pause this. see if 1, 2 works. Put the coordinates in for 1, 2, and that works as well. So 1, 2 is still as good. We have one more to check though. Station C. Put the point 1, 2 in there. Pause it. Come on, give it a try. Put a 1 in for X, a 2 in for Y. And sure enough, the epicenter is at point 1, 2. So we found the epicenter by graphing. That's another reason why you really need some graph paper. And there are 2 ways of getting it. Remember, I put some on the blackboard for you in the content area. And also, you can find some at mathbits.org. If you look at the web page, go down a little ways, somewhere in here, and you've got plenty of choices. I think you've got over 30 different kinds of graph paper. Certainly, several of those will appeal to you. Well, that's it for circles. We're moving on. Section 3 coming up next. We'll see you there.